Let's build a linked list. It's actually quite simple. If we understand what happens in memory, then we create a linked list. So here is the process map, which shows call stack at the bottom and heap where most of the linked list gets created. So what do we need? First of all, we need to define every node of the linked list. In JavaScript, we would create a class, constructor, set the value, and say next is null for the time being. But the same thing can be done in different languages. So here are examples of C, Java, Python, or C++. Basically, all of them have the same thing, a value that it keeps and a reference to the next node in the linked list. So a node would probably look like this, a value and memory address of the next node. So here we go. Now, what do we need to create multiple nodes in a linked list? When the program runs, it creates a stack frame or a function execution context for the first method that gets called, which may be main, anonymous, or whatever that language calls its first method. Now, to create a linked list, we must create a node. Let's call it spot. It's like a treasure hunt where you keep a part of treasure, which is the value, and a hint or clue about the next spot. So let's say we create the first node and store value 5 in it. Now this gets allocated into the heap, and this is the address in heap when we say new spot. However, because this is the first spot, we haven't decided the next one, and therefore the address is 0. Now, how do we know this is the first spot? So to do this, we can keep a separate pointer called head. Head usually means the first node in the linked list. So to do that, we simply say head is equal to spot. But this also happens to be the last one so far. So we maintain another pointer, tail. Tail also points to the same node. Now our linked list has one node with value 5. If you want to add more, we can again say spot equal to new node, which creates another node. Again, this is null, but now we have to go back and connect the first piece of treasure using the clue to this new spot. Now we have tail, which is pointing to this. So we can say tail next is equal to spot. So when we say tail next is equal to spot, it copies this address into the next of the tail, causing the tail to point to this new node. Having done this, 5 is no longer the tail node. So we can say tail should move to the new spot. Now we have two nodes, 5 and 7. Next of 5 is pointing to 7, and so far 7 is not pointing to anything else until we create the next node. Now head is pointing to 5, which is the first node. Tail is pointing to 7, which is so far the last node. But now we are adding another, which is 1. Now we can take this address 500, store it in tail next, and this would cause 7 to point to 1. And this process repeats with tail now moving to the last spot. See, it's easy to build a linked list. Now let's take a look at code. We start with class node and a constructor where we set the value and next to null. This is exactly what we are doing here. Now the list class contains head and tail. So these two fields, will be held in the list class. So we provide head as null, tail as null. Now whenever we say add a value to back of the linked list, which is what we have been doing here, we are always adding it to the tail. We can create a new spot. That's what we are doing here. We say spot is equal to new node. First time, we would assign it to the head. So we check if head is null, which will happen only once. Then we say OK. Then the head points to spot. But if it is not the first time, we have seen that we would assign the tail next to point to this new node called spot. Eventually, we move the tail to new node. So finally, we will have this tail which will point to the newly created node. Time to check it out. Let's write a simple print function which starts from head, goes up to null, prints the value, and then moves to the next node. So we would start from here, print 5, go to the next node, which is not null, so 7, go to the next node, which is 500. Print 1, go to the next node, which is now null, and therefore we would stop printing. Create a new list, add values like 5, 7, 1, and print. So let's run this, and we can see that it has printed 5, 7, and 1. So this is the entire code that we can see. And this is the concept visualization of how easy it is to build, not just linked lists. Any data structure which we can visualize on how it would be created, constructed in memory, we would be able to write code for it.